Love that American lady. Right, everyone. So welcome very much. It's 3 minutes past 7. I still have a few people joining us. I'll keep an eye on that, but welcome to this evening. So, as I said earlier, this is the first in a series of talks from members of the Research and Monitoring Group, of which we have some excellent people in there. One of my favourite people, Dr. Ken Collins, Metris Research Fellow and Diving Officer, Ocean and Earth Science National Oceanography Centre for the University of Southampton. But I just know him as Ken, who has a border collie like me, so that's probably why he's one of my favourite people. But Ken is a great speaker, and I hope you really enjoy tonight. We're calling this series Studland's Ocean Meadows. I really hope you do learn more than you did at the start, and I hope you really enjoy it. So feel free if you want to get yourself a cup of tea or whatever as we're going, that's absolutely fine. Just reminding everybody of the Studland Bay Marine Partnership mission statement. It is a very collaborative group. It's a very mixed group. Ken sits on the steering group. He represents the research and monitoring team within that. This is all about ensuring that things that everybody enjoys doing in that beautiful place that is Studland can still happen, but we really want people to understand what's happening beneath the waves. Also wanted to very quickly, before we start with Ken, just share the map of the Marine Conservation Zone. Sometimes I show this to people. It's quite useful so that they can see where the voluntary no anchor zone is, which is this blue area at the bottom. Obviously, we've got Dorset's largest seagrass meadow. And I'm going to stop my share because we're going to move on to my rock star, who is Ken, of course. And if you don't mind, I just need to very quickly escape from that. I have Ken's presentation. So I'll just get that up on the screen. I'm going to share it. I'll just open it in screen mode, Ken. Okay, and share your screen. And okay, is it up and running?
Super. Well, good evening, everyone, especially to the man who's driving. Next slide. Right, I'm very old. Back in 1990, BP were running, were operating from the Arn Peninsula and an island in Poole Bay, Europe's largest onshore oil field. Click for the next the animation. Should get a little oil well coming up. Excellent. Okay, so that's quite amazing. And the geology of Dorset is such that the strata are very fractured, so the oil lives in little pockets. So they're perpetually drilling to tap into these little pockets of oil rather than the sort of textbook of one big dome and you suck it dry. So back in 1990, said, well, if we're going to tap into pockets of oil underneath Poole Bay, we need an artificial island. Click. There, artificial island. And so, and we'll put our oil drilling rigs on there, and then click. And then we'll build a pipeline to bring the oil from the artificial island back to the Arn Peninsula gathering station. And click. And the only trouble is it's a rich habitats underwater, Merle offer Ballard Down, which we've discovered, and in Studland Bay, seagrass. Click. So, and click again. So the Merle became part of the Purbeck Coast Marine Conservation Zone in 2019, and click. Similarly, the seagrass was the main feature of the Studland Bay Marine Conservation Zone in 19. So BP, going to put a pipeline ashore through the Studland Peninsula and so on. So we want to know what the marine habitats are and set about surveying them. Next. So back in those days, the only computer I had was a BBC. So we didn't have any graphics on computers. I didn't have GPS, used a simple sextant for position fixing, and with a bit of diving then and just going about in a boat, produced this map of the seagrass in Studland Bay. Next slide. Well, actually, there's 1.5 million square meters of seagrass in Studland Bay, and diving it is not the most efficient way of doing it. And at that time, I said I need a video sledge. So I took the roof rack off of my Mini, strapped a video camera to it, and towed it over the seabed. This is a much more recent version. I'm out with my students in Southampton water. On the right is the sledge. There is a video camera and lighting and the aluminium frame, and in the middle is a GoPro. And then so I'm transmitting video to a monitor on the desk, which the two students are watching, and recording in high definition with the GoPro action cam. Next. Right, and so this is sort of one of the more recent maps I've produced of the seagrass in Studland Bay, and the red crosses are the eco moorings that I'll talk about shortly, or the initial eco moorings we installed, and just compare that to click the map I did in 1990. So this is a very recent map, an older one, and basically got it sort of right. In the south, sort of bands of seagrass going out from the shore, a gap, and then less dense seagrass further north. So, you know, on the whole, didn't a fair stab, and basically said, well, if you're going to put a pipeline through, go further north of the seagrass. But the bottom line is that in the same year as doing these surveys, the drilling technology advanced immensely, sort of an order of magnitude. And from onshore, they could reach out into out into Poole Bay without needing to build an artificial island, which was, so we didn't have a pipeline going through the Studland Peninsula, which is great relief to everyone. Next. So why is the seagrass in Studland Bay? Well, the cliffs protect the bay from prevailing winds from the southwest, and it's very shallow. And so shallow protected water, draw a line from across the bay, and you've got all of it is less than 5 meters deep, ideal for the seagrass to grow, and particularly sheltered in the south. Next slide, please. And a lot of things create living habitats underwater, and my international reputation is actually for building artificial reefs for fisheries. So on the left, the picture of the diver is a tire reef with corals growing in the Red Sea. In the middle is our little artificial reef in Poole Bay, made of concrete blocks. And over on the right, this is some oyster reef units that went in recently in the Solent, part of a European project. But basically, reefs, seagrass meadows, other living habitats, mangroves and so on, provide shelter for a variety of creatures, so they can breed and so on. So the seabed on the whole, most of the seabed is flat, and anywhere you add some structure, habitat diversity, to the seabed, there are hiding places for the little guys. Next. The value of seagrasses is recognised worldwide. Lots of here's an United Nations Environment Programme report, the value of seagrasses to the environment and people. Next. And a nice summary of the things that can impact it: boating, temperature increase, industrial runoff, dredging, and so and invasive species, and generally harvesting. So there's a lot of things which threaten it, and generally seagrass is under threat because it lives in coastal waters around the world, and they are under pressure from us humans. Next. And Project Seagrass has a very good website worth looking at. Next. And explains that quite simply the value of seagrasses, biodiversity, fisheries, and so on. The one thing which is in some doubt, quite honestly, as a scientist, the carbon sequestration, locking up carbon long term, is possibly sometimes overstated for seagrass meadows, but not to say it doesn't, but it's an interesting story that many people are investigating. But there's no doubt of the value of seagrass. Next. Right, back to Studland Bay. The problem with Studland Bay is it's easy reach of boats from Poole Harbour. And so, on a sunny summer's day, you can get easily a couple of hundred boats, and the impact, and so there are a limited number of chain moorings which impact the seabed, and also dropping anchors is gradually destroying the seabed. Next. So you dive, you can, on a good day, clear day. I was out at sea yesterday diving and could see the holes in the seagrass like this. Next. And underwater, the anchor point for a chain mooring which drags around and destroys the seagrass in a circle around it. Next. And then from the air, you can see the holes, and each of these is so for instance, there's at the bottom, there's a boat there attached to a buoy, and there's a circle of chain which drags around the seabed, and that's a bare area, typically about 20 meters across. Next. The other way of viewing, because the water is not always clear, is I use sonar, sound. So it doesn't matter how murky the water is, you can still see it. And I use side scan sonar, which gives me an acoustic map of the seabed. And so in the picture, so the bottom, the left-hand picture, can see the mooring chain coming up. There isn't a boat attached to it, and it's that chain which drags around, creating that hole. The dark bit is the sand, the lighter bit is the seagrass. Over here, the chain is coming off to the right, and a hole here. Next. So, and the other thing is simply dropping an anchor. And the anchor digs in, and you lift it up. And the trouble is, seagrass has a rhizome structure. And so when you dig it in, you tear up, the anchor digs in, you pull it up, and then you tear up the root system. And that can take a long time to repair. So we've got all these little holes from every time someone has dropped an anchor and pulled it up. So lots of those in Studland Bay. Next. Right. Okay, got concerns. Now, back in the 90s, the UK Biodiversity Action Plan drew up a list of priority species. And it was kind of interesting because asking the nature conservation bodies, why did you choose them? Why have you missed out X, Y, Z? And they said, oh, don't worry, we can add them later. So from the beginning, seagrass beds were protected. And thanks to Neil Garrick Maidment, he, as a director of this and founder of the Seahorse Trust, he campaigned for including our 2 UK species of seahorses in that biodiversity action plan. And the great thing was that not only were the seahorses protected, but the habitat which they're often associated with, seagrass, was in theory protected. And so Neil led the campaign with Natural England up in Westminster, saying, look, you've got this legislation which says seagrass and their habitat, the seahorse, and the seahorses living in there should be protected. So let's protect Studland Bay. Next. And done various research on these holes in the seagrass, and so one of the things is sort of looking. There's a bare patch, and the sand is very mobile here because wave action washes out the silt. At the edge, there's actually a lip, and looking at some of these holes, you can see crabs living under the rhizome layer. And the trouble is, in storms, this sand, without the silt sticking it together, gets washed away. It's like a washing machine, and these holes drop in level below the seagrass mat, so making it difficult for it to recover. Next. I had one of my very nice Finnish lady did a study on what's growing in the different sediments, and so small creatures that live in the sediments. And there's certainly the black markers are where the number of individuals live, small organisms living in the sediment, in amongst the seagrass bed where it's more silty, and then out in these bare patches, the white columns are showing a lesser number of individuals, and equally the bottom graph, you can see lesser number of simply numbers of different types of species. Next. I worked with the Marine Biological Association in Plymouth, and using my video sledge and to map the seagrass quite extensively in about 2011, and then also making use of existing aerial photographs, produced this comprehensive map of seagrass. And the most important thing about this report is that we were warning about the fragmentation of the seagrass. If you keep making holes in the seagrass, the whole thing will collapse and wash away. And I liken this to, I have favourite woolly jumpers, and I really don't I really tend to ignore when they get holes in them. And if you get many holes in a woolly jumper, the whole thing will fall off of you. And so, this fragmentation with storm actions and the whole seagrass bed could just simply wash away eventually because it doesn't hang together. Next. Yeah, we had 10 years of, quite honestly, vitriolic argument about trying to protect Studland Bay. Conservationists understood the problem, but there was a very vociferous anti-protection for Studland seabed. And some of it, there is no problem. It's exactly like Trump, fake news and climate change. It's not a problem. And equally, I think linked to this is reluctant, well, if we make it protected, then, it'll stop boat owners using the bay, or they may have to pay to use the bay and so on. So it really was an appalling time. I've been involved in creating marine protected areas, involved with the Kimmeridge Marine Reserve in my early days in the 70s, off of Kimmeridge, now the South Purbeck, part of the South Purbeck Coast Marine Conservation Zone, up through in end of 90s, 2000, very been involved with Galapagos, the establishment of the Galapagos Marine Reserve. And during this time I said, I wonder if I'm actually going to see Studland protected whilst I'm still alive. It's sort of my wish to see Studland protected before I die. Next. Well, I didn't die in 2019. And finally, the Studland Bay Marine Conservation Zone was, declared when, part of the legislation, it is declared. There's only one trouble then. There was sort of, we recognise it as valuable, but we're not going to do anything about it, which is what I call a paper reserve. The trouble with Galapagos, when I got involved with it, it was a paper reserve and nobody was doing anything to manage it. And, I sort of felt the same here. Next. So, Sarah's already shown you this map of the conservation zone encompassing the whole of Studland Bay. Next. And then, so a couple of years later, the Marine Management Organisation declared a voluntary no anchor zone. So, please don't anchor where there's seagrass. There's nothing to stop people doing it. There's no penalty for doing so. And the argument was, well, if you don't respect it, then we'll make it legally binding and fine people for anchoring in the bay in due course. But so it's a strange thing, which is where next. Well, instead of anchoring, using moorings, but eco-friendly moorings, and so a traditional mooring is a chain which drags over the seabed. The moorings we're using in Studland Bay is a screw-in anchor about 2 meters long, which goes into the seabed, and a rubber riser, so stretchy, and so there's nothing touching the seabed. Down in Plymouth, they've experimented simply adding floats to the chain to keep the chain off the seabed, called a Sterling mooring. Next. So the big breakthrough came in 2021. Michael Prideaux, the director of Boatfolk Marinas, large company owning many marinas in the UK, and he said to Neil, what can we do to help? And Neil said, well, can you help us pay for 10 eco moorings to demonstrate they're a good idea. And so they went in 21. And next. And so we had, I mean, 10 years of arguments with the anti saying, well, eco moorings don't work and nobody used them anyway. Well, I came up from watching the installation of one of these eco moorings and a boat pulled up as I was still in the water and tied onto the buoy. Putting light to the fact nobody used them, and they are very popular. Next. Right. So I've talked about dragging a video. You can dive and look for seagrass. But the other, and I've talked about dragging a video camera over a seabed. Another rapid way of surveying seagrass is to use an echo sounder. So here I am with one of my students. We're actually surveying the seagrass in Studland Bay with a commercial system. Next. So if any of you are familiar with particularly the colour echo sounders, the sort of orangey line is the seabed, and then if there's any vegetation, seagrass or kelp or something, you get this fuzzy line, and the software in the system simply says, well, I can recognise what's the bottom and I can recognise what's top of the vegetation. I mean, it's fuzzy because the top of the, and so you can get a height of and some idea of the density of the seagrass. You need to check that it's seagrass, but next. And so, so this is a map using the green shading is dark green, dense seagrass, lighter, less seagrass, and with that acoustic system. And then comparing, the only trouble is it only looks at a very narrow bit of seabed below the boat. And so you sort of have to join the dots. And whereas the advantage with side scan is you get a continuous picture. So in this picture, the sort of grey flecks are where side scan has detected on our actual holes, and so the acoustic system, the simple single beam echo sounder is fine, but really doesn't give you the detail. So I always use a variety of techniques. Next. Right. Important question. We put the license for putting eco moorings in insisted there was a monitoring system to see if they were working. Well, it's sort of so 3 years of doing this since installation. Every time I went down, I sort of sat on the bottom, counting and measuring seagrass around the moorings, and thought, why am I doing this? There's nothing of the mooring actually touching the seabed. This is my survey line, the white line, and basically there's no difference. There's been no change in the seagrass shoot depth, number of seagrass plants, or the density of the seagrass, because there's nothing impacting it. Next. Here's more recent, broader scale side scan. The great advantage of side scan is that it's a transducer which sits over the side of the boat and can look 30 meters in the shallow water of Studland Bay. I can look 30 meters either side of the boat and get this almost photographic image of the seabed. So it needs a lot of explanation, but so to the north, you can see a very clear line. That's seagrass above it, and then there's another area, and there's another line here. And carrying across, that seagrass below, and there's a bare area, and there's little clumps of seagrass. And the way of understanding side-scan sonar, and it's looking either side of the boat. So look at the left-hand side of the screen. It's like shining a light in the dark. And so there's a little clump of seagrass, and on one side of it, there's a shadow, because the side scan is coming from the surface, and then you can see a shadow. And on the boat side, the seagrass is reflecting sound back to the boat, so it's bright. And in theory, you can measure the height of the seagrass from this, but it's very clear we've got this band of predominantly no seagrass, which is kind of interesting. Next. And diving now, the seabed is very hard. It's impossible to drive the 2-meter anchor into the seabed any further than this. It's just screwed in, but it couldn't get any further. And the seabed is very stony, shelly, and hard. And you're thinking, I don't think seagrass is ever going to grow in this stony, shelly seabed. And so thinking about it, next, we've got, and this is the bare patch in. So this the dark color is very dense seagrass. This is less dense seagrass, and this is effectively virtually no seagrass, the lighter stuff. So just click, and you should get an arrow appearing. My thought, there's a stream comes into this is South Beach, Studland Bay, and I mean, as little as, sort of 8,000 years ago, sea level was much, Studland Bay would have been dry, and with the retreat of the ice age, the sea level rose, and so I speculate that this bare patch is actually a stream bed because we've already got a stream there. When you go down to the cafe at South Beach, you're going along this side of the stream, and that was the course of that stream going out to sea. So I don't expect seagrass to grow in this particular band ever, but other bits are I think we're going to get seagrass expanding in the future. Next. Right, so with the proving that eco moorings work, we had 10 in the bay, needed more, because with 200 or more boats on a busy weekend appearing, needed more than just 10 eco moorings. And so, and very much the great thing was David Brown, National Trust Ecologist, the chairman of the Studland Bay Marine Partnership, was very much responsible for driving this coalition together. Everybody and used the services of the Dorset Coast Forum to be bringing together government authorities and other research agencies, yachting clubs and so on, bringing together with a neutral, with a much more neutral environment to discuss it. And things advanced very rapidly under David's chairmanship, and particularly Sarah's communication. So it really, and we moved on rapidly. Next. And so, last year had 87 eco moorings in the bay. and that's expensive to maintain. It took £500,000 to get there, and then most of them come out each winter for maintenance and insurance purposes and so on, and then to put them back, as we did just at Easter this year. This maintenance and monitoring, we need to raise the best part of £100,000 a year to keep the system going, and if we can't raise that sort of money, then that'll be the end of the eco moorings. But we're making progress. Next. Right, I must credit the vast number of volunteers working with me to survey underwater, both for seahorses and seagrass, to undertake the studies that we're doing. So, and I now have an email list reaching about 70 people for this year to come and join in with surveys roughly every 2 weeks. So here they are on South Beach. Next. And fabulous place. There's divers getting ready to go, just come out the water. The technique, I supply each pair of divers with a buoy with a little GPS tracker on it, and I give the camera, the divers a little GoPro action cam video, waterproof with camera, and with the same time as in time with real time, and so they can record what they see underwater, and then by using the time as my link to the GPS time, can have the position. So it might be a seahorse, it might be the start of a seagrass bed, the end of a seagrass bed, holes, and so on, or other interesting features. And so it's using the camera as an underwater notebook with a position supplied by the buoy, because GPS does not work underwater. Next. And one of the things that we get inshore is an invasive species, sargassum, came into the country in the mid-70s and spread all around the coast. But we find it in shallow, particularly with rocks. But in Studland Bay, it's typically doesn't go any deeper than a metre below seabed. So it's not, we find it amongst the seagrass, but normally attached to rocks. So it's one of the concerns, will invasive species be actually impacting the seagrass? And my impression is it is not. Next. So very easy weed to identify. If you see a weed on the beach and with lots of little knobbles, pick it up, stretch it out, and if it does the washing line trick, as this young lady is doing, that's your indicator that you're dealing with Sargassum muticum. Used to be called japweed because it came from Japan. What do we call it now?
Wireweed, I think.
It's called wireweed to be more politically correct, but I'm old, so I don't quite understand these things. But it's an interesting weed, worth picking up, because that washing line trick is there's no other seaweed that does that. Next. Right. Okay. By putting all these eco moorings in, there's no need to, and getting people to respect the no anchoring area. We're no longer tearing up the seagrass with boat anchors. And so last year, my student Arabella looked at the side scan images and sort of measured them from before the eco moorings went in till last year. We did surveys, and so it's very easy to measure the area of that hole, and in 2021 that may have been about 400 meters squared in total area, and then in 24 dropped to half of that. And so very, very definite recovery of the seagrass. Now it's no longer being impacted by anchors, so a very encouraging sign. Next. A fun study by one of my students, who's a keen paddle boarder, she and snorkeler. She said, well, I'd like to look at the fish that live in the seagrass and also in the bare patches. And so she basically tied one of these video cameras to a brick, paddled out to sea, dropped a camera in a bare area, but dropped another camera in seagrass, and they run for about an hour, and then analysed the video. And her incredibly clever find was this thwaite shad, a relatively, something we didn't know. And so, and next, and then it's not that there's more fish in the seagrass, or no, there's not necessarily more fish in the seagrass than in the bare areas. They're different. So one fish that's common to both and similar numbers are the predatory bass, the big guys who eat most of the other fishes. And so some prefer seagrass, some prefer little gobies, prefer the bare areas. So it's a fascinating behaviour by just an ordinary, a standard BSc student. And so it's very much, a fascinating study which we were able to publish. Next. We have within the University of Southampton, we have a considerable interest in autonomous vehicles, robotics. So this is a robotic catamaran, set it to, and it can survey the seabed on a pre-programmed route, looking at the seabed, and so using typically using an echo sounder, as I've described before. And another more amazing bit of technology next is a small robot submarine. And so that's one of my engineering colleagues operates this. I mean, you can use it for tracking along pipelines or cables to wind farms and so on. And so it a couple of years of demonstrations with it, get it to automatically fly a metre off the seabed, because visibility isn't always wonderful. It's got a camera, inertial navigation, you set it off, it knows where it started, and then it can do a pre-programmed route and survey an area of seabed. And the amazing thing is you take a lot of pictures and it's a lot of work to interpret it. But his group, and it's a technique he developed when he was working in Japan, using AI to sort of look at all the images and group the images in degrees of seagrass cover, or bare area or rocky area and so on, and then says, well, can you check that? So instead of looking at 10,000 images, it chucks out 200 and says, can you check what these images are? And so it becomes a very quick way of recognizing seabed types. So an interesting and a fascinating demonstration of this technology. Next. No, I'll jump past the video. Next. Yesterday I was underwater. I'm not try not to boast, but a week ago I was in Galapagos and using photogrammetry to map and make 3D models of corals. And I came home and thought, well, yesterday I was underwater. Why don't I use the same technique to map the seabed? So I take this picture is a photomosaic from something over 200 photographs, so close to the seabed, because and all stitched together accurately, and so it goes a large bare area, a seagrassy area, and then another bare area, and so on. And click, and there's an expansion of it. So there's the tape measure I've laid along the seabed, and that's one of my marker tiles. So I know, and this is a whole load of images stitched together, and I can literally count each blade of the seagrass. So it's an interesting technique, and it's taken me a while. I've been away using mapping corals and thought, why can't I do it with seagrass? And proved it. And I shall do more of that in the future. So next. And fine. One of the other things, water quality monitor. This instrument measures a whole variety of things underwater, but also oxygen. And so I had that deployed last summer. And so this is the results for June. So it's how much oxygen is in the water from 6 in the morning to 6 at night. So click. On a sunny day, it sort of goes up. There's a lot of oxygen produced. And I mean, seagrass is a plant, contains chlorophyll, and it turns carbon dioxide into oxygen. And then click. On a dull day, not much sunlight, doesn't produce much oxygen. I mean, put a pot plant in a darkened room, it doesn't like it. And so it's all very interesting, a very clear pattern. The seagrass is producing oxygen. Click. So I worked out that Studland Bay produced the 1.5 million square meters of it is producing 10 tons of oxygen per day. Well, what can you do with 10 tons of oxygen? So like my students, I Googled how much oxygen do people need, and the International Space Station supplies its astronauts with 1 kilogram of oxygen per day per person. So 10 tons, click, would support 10,000 humans for the day. So on a typical summer's day, we could actually produce the amount of oxygen the population of Swanage need. An interesting fact, and something that we are investigating further. Next. The last bit of technology deployed last year, one of my colleagues in the National Oceanography Centre, specifically employed for his expertise, and they're worried about carbon dioxide leaking out of the seabed if we start burying carbon dioxide from power stations and so on in old oil wells. Will it eventually find its way to the surface? And this machine is basically a very sensitive current meter, measures currents in 3 directions, a very sensitive oxygen probe and a pH probe, and it's capable of doing remarkable things, and really being designed for deployment in the North Sea above an old oil well. And so I said, well, come on, try it in Studland Bay. It's only around the corner. Next. And so here it is underwater. Next. And the results don't mean a lot, other than we can see oxygen increasing during the day. And the most important thing is he had used this, he tested his thing next to volcanic seeps in the Mediterranean on the volcanic part of the coast on seagrass. And so we deployed this at the end of September, in the autumn, not a particularly bright day. And he said, hang about, that seagrass in Studland Bay is producing as much oxygen as sort of much thicker seagrass in the Mediterranean in midsummer. It was dead exciting, and experiments will continue. Next. Finally, if you want to know more about seagrass, there's this wonderful freely available book, the Seagrass Restoration Handbook. It's actually written for non-scientists. So it tells you everything you need to know about seagrass and what we can do to make it recover. And so, do look it up. Seagrass Restoration Handbook. I've contributed to several chapters in there, but it really is a very readable book for local authority and folks and politicians to explain the importance of seagrass. So I will stop there, Sarah, and answer any questions.
Thank you, Ken. So I was so engrossed. Right, lovely. Thanks, Ken. Right, we have 5 minutes, folks. I'm always really good about making sure we do end on time, but you can always contact us after the fact. But if anyone wants to ask a question, feel free to raise your hand. You can use the reactions or just unmute and ask, or pop into the chat. I'm going to quickly have a look around the room. Has anyone got anything specific they would like to ask Ken about? Feel free to unmute.
If there's no questions, Sarah, I'd like to
do the video. Show the video.
I'll show a little bit of video from yesterday.
Cool. Yeah.
Right, so I'm going to share that one. Share.
Yeah, it's happening, Ken.
So this is a bit shaky. It hasn't been edited. It was just, me underwater yesterday. And so this is the base of an eco mooring. And what I'm going to do is zoom in on this little fish living in the eco mooring pipe, which goes post, which goes down into the seabed. And that's a black goby. He lives in there. It's his home in there. And it's quite funny watching him because his eyes follow you round. This is Seb, who was diving with me yesterday. And that's a small fish disappearing. But what struck me about yesterday, because I was trying to map the holes in the seagrass, lot of new growth, particularly this long dust. The seagrass is producing seeds, and what's particularly noticeable, former bare areas, the seagrass grows by underground roots, rhizomes. What's the grass we have? Couch grass, isn't it? Couch grass in the garden. And so very distinctive lines of these roots extending out into the bare areas. So as you go along, you see we've got the bare areas, but so a lot of this is on the edge of the dense seagrass, but every now and then you can see distinct lines of these rhizomes running into the bare area, which is very, very satisfying. So I was a happy man after that dive. So, and this, I mean, this is the edge of the seagrass, and to my mind, and from previous surveys, it's definitely increasing. And recovering and expanding. So here we are coming across a dense band, then another formerly completely bare area, but again, so yeah, I mean, this is on the edge of the seagrass bed, and delighted to, as far as I'm concerned, the seagrass is most definitely expanding.
We have a good video on
the
web page, Ken, don't we? That one. I remember watching it. We all got very excited.
Well, I mean, this is from yesterday. Underwater.
Brilliant. Well, I would definitely recommend everyone keep an eye on the events on the webpage. I'll put them in the chat. Because we will be having Neil Garrett Maidment will be doing a talk. Hopefully over the next few weeks, I'll be putting that up as an event in the same way I did Ken. And if you're on my mailing list, I'll be letting people know. And hopefully,
we got Tony raising his hand.
Oh, Tony, sorry, Tony.
Okay, Ken, when seagrass sequesters carbon, in what form does it do that? I mean, is this like a peat bog, the same way that sequesters carbon? And if so, does this raise the level of the bottom of the area where it's growing, and will that ultimately bring the sea level to almost zero?
No, I think the rise in seabed. No, I mean, I've got a study bed at Calshot in the Solent, and the seagrass itself is very good at trapping sediment. And so, and my favourite photograph is my dog standing on a little island as the tide is coming in of seagrass. A seagrass mound is trapped the sediment, and so the seabed is rising. Typically, the seagrass is raising the level of seabed by about 1 millimetre per year. So that ain't going to keep pace with global warming, but and so the sediment it traps is general organic, and so it's silt rich, fine sediments, carbon rich, and so as that builds up, it is trapping carbon, and then the roots and so on are below. So it is exactly as you say, like a peat bog. And the only trouble is, it is kind of vulnerable to storms. So and one of the absolute pains this year has been a succession, with the nice weather in the spring, of easterly gales, making it impossible to do any work in Studland Bay for a couple of months. And so that can have a destructive effect on the seagrass. But bottom line is, the seagrass actually attenuates wave action. And one of the daft things is, residents of Studland Village who are opposing the seagrass didn't realise that it was actually protecting their coast. Their coast is eroding, and so if you let the seagrass grow, it would erode even faster. So yes, I mean, so that's how it's doing it. Doing it exactly like a peat bog.
Lovely, thank you, Ken. Thank you, Tony, for the question. If you do have more questions, do either pop them in the chat now, because I'll be keeping. I'll be recording what was in the chat, but also do go on the website. My contact details there. We very happy to have people, connect with us and share what we've learned tonight. But Ken, can I just thank you so much, because I know you have been away in the Galapagos, and you've come back and you've suddenly done that. And I do apologise, you had to say next all the time. Ken was going to share the slides, but we had a bit of a tech issue, but I think we did all right, Ken. And I appreciate it so much. I'm going to say a big thank you from everybody who's enjoyed tonight. Please do look out for the rest in the series of talks. It's so interesting. I just love it. I love, particularly the videos are brilliant. So thank you, Ken. Thank you, everybody else, for joining us. Do go to the website. Do tell people. The more people share peer-to-peer, the more this project is reaching a wider audience. And loads of thank you very much, Ken, to you in the chat. So I'm going to say good night and let you all go and enjoy the rest of your sunny evening, and look out for the next events. And thanks again, Ken. I really love that. You're such an entertaining speaker. It's much appreciated. And always with your sidekick, Jenny, who did really well there with the prompts.
Oh, wait, before you go, I saw in the chat briefly, there's I mean, I'm always open. I'm very open to volunteers. And so if you want to volunteer to come diving with me, or even just drop me a line, and any help is welcome.
Excellent.
One of the things I'm short of, I mean, come out to sea, even if you're not a diver, because I dearly need photos of divers.
Yes, we do. We need as many photos as we can. I'm always asking you for photos. Oh, Ken. So yeah,
and
lovely.
So please, if you want to help, contact me.
Lovely, thank you. Right, I'm going to stop recording now. So thank you very much, everybody, for coming, and enjoy the rest of your evening. I'm going to stop the recording. There we go.